Hi, welcome to AB Video 7.2a Part 1, Introduction to Volumes by Revolution. Find the volume. Okay, let me pause for a second here and pull up Calculus in Motion because you're going to want to see this. Okay, so here's an example. The function we have here is y equals root x. We're taking the region, oh God. Oh, I've lost it now. Hold on. All right, so we have our function y equals the square root of x. We have the region bounded by the y equals square root of x, the x-axis, the vertical line x equals a and the vertical line x equals b. Now this is the axis of rotation. I'm going to raise that up to be right on the x-axis. So we're basically going to rotate this flat region around one of its own borders. And when I do that, this would be, for example, quite a few, 5 rectangles, okay? I hide the original area. And now there's the reflected. But what I want you to really see is this. What we're taking is each one of these rectangles, we're rotating it about the x-axis, okay, which is going to give us a disk. Now, hers are kind of wide, I find. Be better, the skinnier they are, the better it would be. So there's the different disks. Now, of course, they all have different volumes, but the point is this. If we add them all up together, the volumes of each one of these disks, which is basically a flat cylinder, then we'll get a good approximation. And of course, because it's an integral, it's going to be the exact value of the volume of the solid of revolution. Now, what's interesting is they don't actually show you, okay. Yeah, they don't show you what you actually get as far as a solid, but that doesn't matter anyways, all right? Okay, now that's for volumes by disks, which is called, okay? So let's go back to our notes. So there's disks and there's washers. So let's take a flat region bounded by y equals f of x, the x-axis, x equals a and x equals b. Or it might be a region bounded by 2 curves, in which case you'll have to find the points of intersection. They're going to have you rotate or revolve that region around either a horizontal line, such as the x-axis or y equals a number, or a vertical line, such as the y-axis or x equals a number. So let's take an example. Let's take the region bounded by these 4 things, which is, of course, this region right here. So you have y equals x squared, the x-axis, x equals 2, and x equals 5. So it's this striped region right here. Now we're going to rotate it about the x-axis. Well, the x-axis is one of its own borders. So you will have what's called a disk. You're going to take and you're going to draw. Now here's the key thing. And that's why it's in stars. You're going to draw somewhere between A and B. You're going to pick an arbitrary spot and you're going to draw a skinny little vertical rectangle. Now the reason it has to be vertical is that it has to be, the rectangular strips must be perpendicular to the axis of rotation. And since the axis of rotation is the x-axis, that means they have to be vertical. And you picture taking this little vertical strip, which goes from the bottom border of the shaded region to the top border. So it would go from this little green bar to this little green bar, and then you're going to rotate it. So whatever the distance is between here and here will be the same as between there and there. You're going to want to be able to draw these. So what you draw is kind of an oval, which represents the top base of the disc, and then you kind of give it a little thickness so that you're actually looking at a cylinder. Now, the formula for the volume of a cylinder is pi r squared h, the area of the base times the height. In our particular case, the radius, if you looked at this arbitrary point x, y on the curve, the radius is actually the y coordinate because it's the height of the point. The height of the cylinder or the disk is horizontal and therefore dx. So what happens is you end up with pi, and then you're going to accumulate all those different cylinders. And then you have your r squared, which we agreed our radius is our y coordinate of that point, squared, and then the h is dx. Now, it's very important, this dx, because it's the tail that's going to wag this dog, which is everything has to be in terms of x. So this has to be in terms of x, which means it's the left border, x equals 2. This has to be in terms of x, so it's the right border, x equals 5. But you have to also change this y into x. Well, of course, that point is sitting on the curve y equals x squared, so you simply replace the y by x squared. And then you're integrating x to the fourth dx. Very easy to do, okay? So basically, if when you rotate, you're rotating on an edge of the region, then you're going to get a disk, in which case the formula will be pi times the integral of r squared h. Your h, figure that out first. Is it horizontal or vertical? And that's because the rectangular strips have to be perpendicular to the axis of rotation. And then depending on whether that's dx or dy, that determines whether these limits of integration are x equals to x equals, which is left border, right border, or y equals to y equals, which is bottom border to top border. This also will determine whether this radius has to be expressed in terms of x or y. Okay, so here's an actual example. Let's take from 3 to 7. So we have y equals root x from 3 to 7. This is like the one in the video. I'm rotating on a border, with the border being the x-axis, so I'm revolving around the x-axis, so there won't be a gap, so it'll be a cylinder, which is a disk because it's really flat, so it'll be pi integral r squared h. The h is dx. As you can see, the height of my cylinder is actually horizontal, so it's dx. The radius, as you can see over here, of my cylinder is the y coordinate of that point. But I have to change everything into x, and y is equal to root x. So I simply replace y by root x and squared. And of course, my limits of integration have to be in terms of x, which is left border, x equals 3, right border, x equals 7. And you could take it from there. Numbers 1 through 6 set up and evaluate the integral that gives the volume of the solid formed by revolving the region about the x-axis. So all of these are going to be revolved about the x-axis. Now, what they don't tell you is the first, they meant to say the first quadrant region bounded by y equals 4 minus x squared, the x-axis, and the y-axis. So you should know, of course, the y equals negative x squared plus 4 would be this parabola, turning down with a vertex at 0, 4. And we're just going to look at the first quadrant. It's confusing to make you think it's because it wouldn't be bordered by the x-axis and the y-axis if you took the whole thing. So it's either the second quadrant version that's bordered by the x-axis, the y-axis, and the curve, or the first quadrant portion, which is bordered by the y-axis, the x-axis, and the curve. So I'll take this one. You will need to figure out what the x-intercepts are. So if you factor, this becomes 2 plus x, 2 minus x. So the x-intercepts are at 2 and negative 2. We already know the vertex is at 0, 4. So here's our region, and they told us to revolve about the x-axis. So our rectangular strip has to be perpendicular to the axis of rotation, so it has to be vertical. You're going to take that little rectangular strip and rotate it about the x-axis, and it's rotating on one of its own borders, so you will get a disk. Our radius, as you can see, again, is the y coordinate of the point. And once again, our height is horizontal, so it's dx. So h is dx. The radius is actually y, but what is y equal to? Y equals 4 minus x squared. It has to be all in terms of x. Don't forget the square. And the left border is x equals 0, right border is x equals 2. Do not forget the pi. And then you're going to integrate, etc., etc. Okay, here's another one. Region bounded by y equals the square root of 9 minus x squared. Sorry. I think this is copied. I don't know that I can. Yeah, it's just a picture. I can't change that. Okay, so it's square root 9 minus x squared, x-axis and y-axis. Square both sides of this. You'll see that it is a circle, center origin radius 3. Once again, if it has to be bordered by this circle, the x-axis, and if this half circle, right, this top circle, because it's positive square root, x-axis and y-axis, they're either talking about the second quadrant version or the first quadrant. I'll go with the first quadrant version. So here's our graph. That's 3, 0, that's 0, 3. Because the axis of rotation is the x-axis, which is horizontal, we have to draw our little vertical strip as vertical, perpendicular to the x-axis. Now you're going to picture taking that and rotating it about the x-axis. You'll get this disk. The radius of this disk, again, is the y coordinate of the point. And again, the height of our disk is dx. So it's pi r squared h is dx, everything's in terms of x, the left border is x equals 0, the right border is x equals 3, and even though the radius is y, I do have to change it into x. So if y squared is 9 minus x, well, they gave you a y equals square root of 9 minus x squared. And then you're squaring the radius, so you'll square the square root, it'll disappear, etc.,